Hello everyone, this is Sabita Sunkara and welcome back to our Enterprise Data Engineer interview series. In today's episode, we are discussing one of the most important ETL interview questions. What is the difference between full load and incremental load? Which one would you choose in production and why? So many candidates answer this by saying full load loads everything, incremental loads only change your data. While that's technically correct, but interviewers expect much more from an experienced data engineer. So they want to understand how you think, how you make architectural decisions, and how you solve production problems. Let's understand this using a real enterprise scenario. Imagine I'm working for a global retail company like Amazon or Walmart. So every day, millions of customer orders, payment transactions, inventory updates, and shipment details are generated. Over the years, the data warehouse has grown up to store billions of records. So now, suppose today's source system contains only 50,000 new records or modified records. The question is, should I reload the entire table containing million of records, or should I process only the records that changed today? So if I reload everything every night, the ETL job will take much longer. So it will consume more CPU, memory, storage, and network bandwidth. So as the data grows, the processing window keeps increasing, and eventually the report may not be ready when the business starts its day. So instead, if I definitely or if I identify only the new and modified records, I can process a much smaller data set. So this reduces execution time, lowers infrastructure cost, and makes the pipeline more scalable. So that's why experienced data engineers don't immediately think about technology. They first understand the business requirements, the data volume, and the available ETL window before deciding on the loading strategy. So now let's compare both approaches. Okay, let's start with full load. In full load, every time the ETL job runs, it extracts the entire dataset from the source. In many cases, the target table is truncated or deleted, and then all records are loaded again. So, this approach is very simple because there is no need to identify which records changed, right? It's useful during the initial load, one time migrations, or for small lookup tables. However, as the data grows, full load becomes inefficient. So every execution consumes more resources, increases ETL duration, and raises storage and computed cost. Now let's look at incremental load. So here, instead of processing everything, the ETL pipeline identifies only the records that are new or have changed since the last successful execution. So this is usually done using timestamps, watermark columns, change data captures, CDC, that is SQL change tracking, or delta change data feeds. So only the delta records are extracted, validated, and merged into the target tables. So this approach is much faster, uses fewer resources, and is the standard approach in most enterprise production environments. One thing I always tell in interviews in this, both approaches move data from source to target. The real difference is how much data is processed during each execution. So let's walk through the entire incremental load process. A customer places an order through the website. The order is stored in the OLTP database. Then, when the ETL pipeline starts, it does not read the entire orders table. Instead, it checks a watermark value or timestamp to determine the last successful load. So then, using that information, it extracts only the records that are new or updated after that point. So these delta records are first loaded into a staging area. Then Before loading them into the target table, several validation steps take to place. So we have validate mandatory fields, remove duplicates, verify referential integrity, apply business rules, and compare row counts. Then once validation is complete, we use a merge statement or upset, that is update or insert operation, to insert new records and update existing ones, right? That is upset operation. Okay, after a successful load, the watermark table is updated with the latest processed timestamp. So this ensures that the next ETL run starts from the correct point. Finally, Power BI dashboards and reporting systems are refreshed using the updated data. This entire process avoids unnecessary processing and makes enterprise pipeline much more efficient. Then this is the part that separates experienced data engineers from beginners. So the best practices is implementing incremental load is not just about loading fewer records. It's about loading the right records correctly every time. So the first priority is data quality. Before merging records, we have to validate schema, check for null values, remove duplicates, verify business rules, and ensure referential integrity. Next comes performance optimization. Here we have to create indexes on watermark columns, partition large tables, then batch merge operations, and avoid unnecessary select star statements, right? These small optimization have a huge impact on large data sets. Then monitoring is equally important. Every ETL execution records the number of inserted, updated, and failed records. So we have to monitor execution time, data freshness, and SLA compliances. If anything fails, alerts are automatically generated. Then the governance and reliability are also critical. Here we have to maintain watermark tables, then implement idempotent processing, so rerunning a job does not create duplicates. Then unlog every execution for auditing and troubleshooting. Finally, there are some common mistakes we have always avoid: using the wrong watermark column. Okay, then ignoring deleting records, missing late arriving data, then running very large merge operations without batching, then forgetting audit and monitoring. Incremental load is successful only when it's accurate, reliable, and easy to maintain, right? So now if an interviewer asks when would you use full load and when would you choose incremental load, this is how we have to answer. So for our first step is always to understand the business requirement. Then analyze the table size, daily data growth, ETL window, reporting, SLA, and business expectations. Then after, if it's an initial migration, a small lookup tables, then we are using, or a one-time load, we have to prefer full load because it's simple and does not require complex changes or complex change detections logically, right? However, for large production tables with the daily or frequent data changes, we have always recommend incremental load. So when we implement incremental load using timestamps, watermark columns, CDC, SQL change trackings, or delta change data feeds, depending on the technology stack. So we also ensure that every load includes validation, audit logging, error handling, duplicate prevention, and monitoring. So in my experience, full load is mainly used for initial or exceptional scenarios. Incremental load is the preferred approach for enterprise production systems because it minimizes processing time, reduces infrastructure cost, scales efficiently as data grows, and still maintain high data quality and reliability. So here are few practical tips from real projects. So don't choose incremental load just because it's faster. Make sure your change detection logic is accurate. Then always maintain a reliable watermark or CDC mechanism. Then handle inserts, updates and deletes correctly. Also build audit tables in every load can be traced and validated. So test for late arriving data because it's very common in production systems. Then so that brings us to the end of the today's episode on incremental load versus full load. So here the takeaway point is full load is simple, but incremental load is the enterprise standard because it processes only what changed, reduced cost and improving performance and scaling efficiently as data grows. So if you found this video helpful, please like, share and subscribe to the channel. Don't forget to press the notification bell so you never miss our upcoming Enterprise Data Engineer interview series. Thanks for watching, and I will see you in the next episode where we will discuss change data capture, that is CDC. Thank you.